Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video we are going to work out a problem on the section of a square pyramid which is resting on HP on one of its triangular faces and is cut by a horizontal section plane. Friends, the question for today's video reads like this. A square pyramid of base 30 mm and axis 65 mm long is resting on one of its triangular faces on HP. So basically we have to start with the initial position of the object. So we have to place the object on HP such that one of the triangular faces of the pyramid is to your right side. So I am going to get the top and front views of the pyramid. Friends, it is a square pyramid. Since it has to rest on one of the triangular faces on HP, I am going to place the object on HP such that one of the side is perpendicular to VP. So this is 30 SQ. It is a square of 30 millimeter side, and we'll name this as A, B, C, D. This is O comma O1. O1 is the center of the base and O is the vertex of the pyramid. We will project all these points and obtain A dash, B dash, one of the sides here. This is C dash, D dash. You locate the vertex of the solid which is at a height of 70 millimeter. They have given you, sorry, it is 65 millimeter. So this height of the solid is 65 mm. Now this is O dash, this is O1 dash. Friends, the last line to the right side of you is one of the triangular faces. So I will say this is one of the triangular faces. Friends, in the question it is given that it is resting on triangular face. So I have to redraw the front view so that this triangular face is on HP. So friends, we have to just copy this figure and get the second position of this solid in which this triangular face, that is, this point is going to become A dash, B dash, this is C dash, D dash, and this is O1 dash, this is O dash. Friends, we have to obtain this so-called top view for this. So we'll just write lines from all these. Obtain the base. Base is again A, B, C, D. AB will be 30. This is C comma D. And we have this O, the vertex. So we'll write a horizontal line from here and obtain what is the axis. This is O comma O1. And we'll join all these by very thin lines to start with. And then we will see what happens to the final figure. So I have joined all these corners to the vertex, and this is how the pyramid looks in the top view. Now friends, it says it is being cut by a horizontal section plane passing through, which is normal and parallel to HP. The section plane passes through the base center, Base center is O1, that is O1 dash. So I have to write a horizontal line representing the section plane SS. This is horizontal and passing through O1 dash, the center of the base. Now friends, the section plane is cutting the base of the solid here. To know where exactly it is cutting, I am going to write a vertical line through that. Friends, it is cutting this AD here and also this BC at this point. So we will say this is point 1 and this is point 2. We will mark them here. Friends, the section plane is also cutting the slant edges O dash A dash and O dash B dash. So friends, I have to write a vertical line from there to know where exactly is cutting the other two generators. So it is cutting O dash A dash and O dash B dash. This is O dash B dash. It is cutting somewhere here and O dash A dash is here. So these are the points where the section plane is cutting the slant edges OA and OB. So we join them by straight line. So this is point number 3, point number 4. This is 3, 4. So totally we have got 4 points. Since this is a pyramid, join all these by straight line. So 1 to 2 I am going to join here. This 3 to 4, again these I am going to join. So I have joined all these 4 points and I am going to section that figure 1, 2, 3, 4. Friends, after completion of this, friends, we will see what is the portion that is left over. So this portion is retained and this you have to show by full line. This is by full line and this portion AB is removed by section plane because it's totally removed, and this has to be AB, right? Sorry, this is AB, this is A and this is B. This becomes C and D because in the pyramids when they are resting on HP the position gets interchanged. So friends, it is on OA OB we have taken correctly. This is how we obtain the sectional top view of the solid. So this figure, friends, is the total figure is sectional top view because it is shown hatched, and this shaded area, the shaded area is the true shape of section, is the true shape. So the shade area becomes the true shape, and here we have to darken the portion that is retained. So this I am going to show by visible lines. This is visible lines and this by visible line. This portion above this is removed. Friends, this figure represents the front view of the solid. This is the top view with the section, that is sectional top view, and the pyramid is resting on OCD. OCD is one of the triangular faces on HP. Friends, since the section plane is horizontal, whenever any object is cut by a horizontal section plane, the hatched area or the sectioned part of the solid in the top view represents the true shape of the solid. And if they ask you to name the true shape, this true shape is a trapezium. It is a trapezium. They will ask you in the examination, name the true shape of the curve. So this is a trapezium. Similarly, friends, whenever a solid is cut by a vertical section plane which is parallel to VP, just like a plane like this, whether it is a pyramid, a prism or a cube, whatever it may be, whatever the area you get in the front view, that is sectional front view, hatched in the figure will represent the true shape of the figure. Friends, I hope the presentation was interesting on this section of square pyramid. If you like this video, please share with your friends without fail. Thank you very much for watching my YouTube video. Have a wonderful day.